So, welcome to my presentation about relaxed releases with DB-Workload-Test. First of all, a few words about me. Who am I? I'm Martin, working as a BI engineer and as a DBA for a certain amount of time, and basically doing all about data at the company I work with, 3C Deutschland in Heilbronn in Germany. We also have a job opening for a DBA. So if you're motivated and you speak a basic level of German, let me know. I would be very interested. And I'm excited about PaaS for a very long time, since 2008, and thought I could do something about giving something back, switching the role from a spectator to a presenter. And now that's here my first attempt today at New Stars of Data, and I'm very honored to be here. So what we're gonna cover today. First of all, we're going to talk about why doing workload testing at all. Why should I care? Then how to perform workload testing using workload tools. Of course, I'll show you some demos, give you tips and tricks, and I'd like to take questions at the end. You can simply ask them in the chat, and I'm sure Kendra will hand them over to me at the end of the presentation. So, why do we do workload testing? So it's about a very basic thing, but which is still a very relevant, small changes and possibly big impact. For example, in performance tuning, we might think about altering an index. Satya did a great job beforehand covering index bases. And of course, queries do change and we do alter indexes. And of course, we do this in mind with the option that the query gets faster, the DML statement. But sometimes we also have a drawback and something else gets slower. So that's something we would like to know ideally beforehand before we go into production with that thing. And we've got some other examples. For example, SQL Server is constantly shipping new features in new version. We've got accelerated database recovery, for example, in 2019, which sounds great. But even Microsoft says, yeah, you've got to have to test it. There's nothing such as a free lunch. And of course, you have to provide the space to do all the logging for it. And yeah, that's something I would like to find out before I go onto production. And we can also think about adjusting some database settings like markstop and so on. And what we can do about it, there's basically three courses of action we could take. We could go for the first action, no risk, no fun. It makes life interesting that something changes and we have some interesting scenarios, or we could go completely the other way. Oh, I'm too scared. If I turn one knob, the whole system will fall over. And yeah, if you're happy with the first two, basically, you can now lean back and relax. It's okay for you. I'm going to talk about a third one. We would like to test our change before we roll out, and we would like to test it thoroughly. So we are going to cover that in more detail. So yeah, testing sounds fine, of course, but how do we do testing? And I thought about it a little bit and basically identified three stages or three ways of doing testing. First of all, we could test a single query. We have one query, we change the query, we throw an index on the table, we test the query, perfect, ship it out. We could go further and test all the queries. So with queries, I mean select statements, so not doing data modification. We could test all the queries on the table, or we can test with the complete workload, and this means in essence read and write activity, so also insert, update, and delete. I've got two hidden slides in my presentation you can get on the handout where I cover the first two. I would like to focus on the third option of the complete workload, and will tell you more about it now. So how would we go about conducting such a database workload test, or also called an A/B test? First of all, we've got our production system with typically in an OLTP environment, such as an ERP system, constantly running a workload, changing every second something. So first of all, we would like to take a backup to have a consistent starting point for our replay, which we would do later. Then next we capture the workload running, so immediately after the backup. And then we can go over to a test instance, to a test in the system. And of course, first of all, we perform a restore. Then next perform the replay and do a second restore. So with the replay, we've got a baseline. We've done no changes. We've simply ran all the workload, all the queries, all the insert updates leads, and know how the initial version looked like. We do the second restore. We implement some changes. We were thinking about altering an index, fiddling with maxstop, whatever. And then we perform a second replay. And then, of course, we've got two results. We've got a baseline result, and we've got a result of our second replay with the changes. We can perform some analysis. And typically, that's not a one-way process. Maybe the first time analyzing, we would find out, okay, that's cool. There's a lot of queries which went better, but a few queries regressed and went slower. And then we would take the feedback loop, go back, do again some changes. And that's basically our life insurance. The great thing about workload tests we can do in order to have smoother releases and not being surprised. So I've already talked about the test system. So here I would like to share some thoughts about it, how to set it up. So first of all, something about sizing. So of course, we are running a production workload. We need to store the production database, so we need to provide sufficient storage capacity. The disks themselves can be slower. For example, in my scenario, we've got SSD on the production server, and on the test server, we're running magnetic spinning disks. So classic ones, but even in a RAID 0 scenario, so that we get maximum performance. Of course, no reliability, but that's not that important on the test system, isn't it? If there's a hardware failure, you simply have to wait for the new hardware to be shipped and you start again. You need to provide the same amount of memory and the same CPU config. As we've got queries running with maxstop settings and so on, it doesn't make sense to have like 12 cores in production and 6 cores on the test system. You have to make sure that you've got the same SQL Server settings. So you set, for example, maxstop identically, and do your due diligence. Ben already mentioned it. We Germans, we are very concerned about GDPR. We take this seriously. But also thinking about the US, you've got CCPA. That's not much different at all. So we have to watch out to make sure that it's okay that we have the data on this separate system. Just talk with your compliance officer and think about security as well. It doesn't make sense that you've got your production data locked into your data center with all that countermeasures against attacks, and the test instance is running under your desk and can be taken easily. So thinking about a workaround, you can also go ahead. I would have some second thoughts about that, but before you don't do this at all, you could have a separate database on your production instance, but then of course you have to perform the workload tests in off-peak hours, for example, over the weekend. And you really cross-check and make sure that the workload test doesn't access your production system, but otherwise you've got a real mess. And the relaxed component doesn't really come in. So, having talked about that, I'm going to head on and present you how to perform workload testing using workload tools specifically. So what's workload tools, first of all? Workload Tools is a great open source program developed by MVP Gianluca Sartori from Italy. So he calls himself Spaghetti DBA, which is quite charming, and enables us to capture workload using profiler, trace, or X events. And that are basically the tools that have been around for years and ages, and enables us to supporting a broad range of SQL Server versions. Gianluca meant you could also use it on SQL 2000. He has tested with 2005. I guess if you're running 2000 by now, you probably have got other problems, but possibly, positively speaking, you could leverage that tool by migrating from 2000 to 2019. What about that? So and capture gets saved in a database itself, which is really nice. It's a SQLite database, which is a file-based database, but you can access it with all the tools with SQL, which we really love and we are familiar with. And you also get, of course, an integrated tool for replay. Most importantly, you can find it on GitHub and download the current version there. So let me talk a little bit about the components of Workload Tools. First of all, and that's the most important tool, we've got SQL Workload, which is doing all the capture and replay of workloads, and that's a command line tool. It's not too complicated, so I'm sure after my presentation, all of you can manage to handle SQL Workload, so don't be afraid of that. Then we've got a nice GUI tool as well, which is Workload Viewer, and Workload Viewer is about the comparison of test results. So all the analysis we conduct has a nice GUI for doing that. And then there's one other tool. If you are long in the business of doing workload testing, you could go ahead and convert your old trace files you've collected, and is also planned to have something of a wizard for making the process of capturing a workload easier, but that's not yet available. And I think it's not the most important thing, because the config, even if it's command line, can be done really nice. So thinking about the configuration, we've got one listener where we can capture from a source via the methods already explained. And we, of course, can read from a captured workload using a file workload listener, which is then reading from a SQLite database. Then we've got possibly multiple consumers, which means we can write a workload to a file if we are capturing from the source. We can gather analysis data using an analysis consumer, and we can replay the workload using a replay consumer. And all the configuration is done in a JSON format. So let's look at a sample configuration for capture. And this is JSON, but it's not too complicated. And you basically simply need to know to fill in the blanks and change it to your system. First of all, we can see we've got a controller instance, then we've got one listener. And the listener is of type extended events workload listener. So we are capturing the workload using X events. Then, of course, we provide some connection information, which server to connect to. Here it's integrated authentication. You could go with username and password as well, as we will see. And that's already optional. You could name a database where you would like to capture the workload. So I'm only capturing workload from the database MyDB, not from the whole server. And subsequently saving the workload to a SQLite database, then I can replay it. You can find a complete reference, of course, on GitHub. And now that we have made data capture, let's think about the replay process and how this works out. And there's some important thing to know, namely how replay gets conducted. If you're capturing, you've got different sessions running, also called spit. And then if we do the replay, each recorded session gets its own replay worker process running independently from the other one. this one executes the commands in the session one after another. And there's an interesting scenario I ran into, namely, you can have a different sequence of execution on the test system than on the prod system. That's a possible problem. I've had workloads where this was happening a lot, and workloads where this wasn't happening at all. But think about it, the replay worker processes run independently. And of course, for example, you've got a SPIT 100, which does an insert. This row has to be there before the update comes along in SPIT 101. And of course, that's important. That's what makes workload testing a little bit harder in the first place to achieve, and why it's not widespread adopted. Anyway, sometimes SPIT 101 might be a little bit faster, and then you've got a foreign key violation. That's simply something you need to know. It doesn't necessarily mean that you cannot profit from the workload. You simply have to work out how this is on your system and with your workload. And then, speaking further about the replay, we've got two options. We can go for a synchronous replay or an asynchronous replay. The synchronous replay respects pauses in the workload, and the asynchronous replay fires commands as quickly as possible, which means with a synchronous replay, the duration resembles the capture duration, more or less. If I do a 1 hour capture on the production system, I can expect the replay to run about 1 hour as well. Of course, if in that hour, let's say nothing really happens, the replay can be significantly shorter if I do it asynchronous, and it simply fires the commands as quickly as possible with no wait in between. And I also have to think about, I'm pushing my test system here harder. That's not the workload like it was occurring on production. This is like, yeah, a speed test or something I would call. And thinking about all the problem of foreign key violations we've talked about, it could be that you've got more errors like this because you're just giving full speed and firing on all cannons at the same time. So, having covered that, we are going to the sample configuration for replay. It's a little bit more lengthy, but it's not too complicated. First of all, we've got a listener again. Here it's a file workload listener. So we're reading from the SQLite database where we just captured the workload in, and we're doing this in synchronous mode. So synchronization mode equals true. It's quite interesting. My opinion that this is configured as a listener, but that's how it is. So we're doing synchronous replay. I already said that. We are connecting again to a server. Here it's the replay server and to the database MyDB. And we can have some optional configuration as well. For example, we can say we don't want to consume results. We discard the results after execution. They don't have to be transmitted over the network. And we have a command timeout after 3 minutes, for example. Of course, doing a replay, we also want to perform some analysis. We do this with the analysis consumer. We give connection information again. We name a server, a database, and the nice thing is we can also give it a schema. So basically, the analysis is written to the same set of tables each time, but we can all store it in one database, just different schema names. And we configure to upload analysis results every 60 seconds, so every minute. So that's the basic configuration you can do, and I'm sure you already grasped this quite good. Now there's also more possibilities to do advanced configuration. First of all, you can do a workload analysis already during the capture, which is quite cool. I'd like to think about it like a mother of all baselines. You've got a baseline on the prod system, and you've got a baseline on the test system, and then you can go ahead and compare is there something different on the test system than on prod. And you can do some really advanced stuff like real-time replay, where Gianluca already blogged about it, which basically is that you don't have a SQLite database. You're doing the capturing and you're doing an instant replay. If you're going for a scenario like this in an OLTP system, typically this would involve some advanced recovering methodologies, like, for example, log shipping, because of course you have to have a consistent starting point on the two instances to be successful with a replay in the first place. Okay, now we've done capturing, we've done the replay. Let's go on for analysis. For analysis, we've got two options. We've got Workload Viewer by Gianluca Santori, which is really a nice graphical tool, which is integrated in Workload Tools and compares core metrics CPU time and elapsed time. As of now, we've got no execution plans, but hey, that's really cool, free graphical tool. It's great, and we've got a backup for this, as I will show you. So that's option one, and as option two, we've got a query store comparison script John Starrett wrote, which is really cool because if you've got SQL Server 2016 and higher, you've got query store and you've got all the analysis possibilities, and you can cover reads and writes as well, for example. And you've got the execution plans at your fingertips. So if you're really into an in-depth analysis, what's happened during the baseline, what's happened during the change, then you can do that. And you've got all the metrics we, as performance tuners, we loved over all the years, which Kendra taught me in the first place. Thanks again. So we can leverage that here. And before showing you some demos and giving some more concrete examples, I would like to share with you what I think is freaking amazing about this tool. I've had a problem. I've wrote Gianluca an email, and just one day later, he already shipped a new release and fixed the bug. Guys, this is absolutely amazing. And this is something I encounter a lot in the SQL Server community. SQL is not just a tool. It's not just a job for most of us. It's part of our lives. We love to play with data, love to speak about SQL, and you really get all these great people here around which are giving back a lot of things to the community. Gianluca is a prime example of that, and I think I'm trying to give my first contribution today as well, not just consuming, but also giving something back, what I learned. So having said that, now I'm going to the demo part. So first of all, let's have a look at the capture process. So with capturing, I've recorded a video just that I can speak more relaxed and don't have to hit a lot of buttons. So first of all, what we're doing here, here's the configuration. It's something like we've seen before. We are capturing using an X events workload listener. Here I'm connecting via username and password. That's because I'm using SQL on Linux on my Docker container here on my Surface. And I'm capturing workload from the Stack Overflow database. So most of you probably know Stack Overflow, and Brent Oser is shipping a great database backup of Stack Overflow posts, which is really nice because it's a real life database and you don't have to inflate it like AdventureWorks or so to get decent results. And most of all, we're writing all the results into the SQLite file. So let's run this. That's the configuration. Now I'm going over to a PowerShell script. Here's a little bit of syntactic sugar. First of all, I'm connecting to the database, and to have a consistent starting point, I'm setting a marked transaction, which I'm going to cover later in more detail. I delete the database if it's already there. And what's most important is here, just on the last line, I'm calling SQL workload exe, providing the JSON config and telling it to write the output into a log file. So guys, this is command line. Okay, you've got a JSON config, but I guess this is something my daughter could do as well. It's not too complicated. So don't be shy of that. Now we're running this. And I get some results. So it's already writing out some logging messages. I'm writing event data to the SQLite file. And now, of course, this is just my local laptop. I have to generate some activity. I do this using SQL query stress by Adam Mechanic. And I have here some simple stored procedures. Brent Osa provided a few of them as well, which is great, to generate some activity on Stack Overflow. So of course, we would like to have to record something more than just system stuff on an idle database. And yes, I see, okay, now there's party on the database, there's happening something. Now I'm gonna set up a timer, and I'm gonna record the workload for half an hour. And of course, you see I've made a video because it's pretty boring. If I would show you the workload running for half an hour, that's not what we are here to do today. And I'm then, let me go ahead. Yeah, I'm then further into the replay. So I've got about 10,000 events after half an hour capture, and then I'm simply shutting it down. Shutting it down is rather easy. You simply hit the stop button or hit Control-C in CMD or PowerShell. I like PowerShell. You don't have to use PowerShell if you don't want to. You can also use good old CMD. And that's it. Then the events, X-event session is deleted on the production system. And there's also a cool thing I really like about the way Gianluca set up this X-event session. It's really lightweight. It doesn't have a big file which could fill up your drive on your production server. It just has a small buffer file. And the worst thing which could happen is simply that you could lose events if Workload Tools isn't getting results quickly enough, but that's rare to observe. So here we see the shutdown message. We are closing the connection. We've got 10,000 events, and we are disposing the listener. And of course, you can double check on the source system, on the production, that you delete the listener if it's the X event session, if it's still around. But typically, that's not the case if you're shut down cleanly. So what we are now left with is a, let me shut this down, is a SQLite, it's a SQLite database. And I've got a free tool here, which is called DB Browser for SQLite, which is like, I would say, Management Studio for SQLite. So you can look at the data and, of course, modify all the data with SQL if you'd like to. And the basic table Gianluca is saving to is the events table. So here you can see all the recorded activity. We can see an application name, where it came from, which is, of course, more interesting on a production system than here in my local machine. And I see the query text, which in my case is simply these procedure calls. And I already get, which is pretty cool, some basic metrics like CPU duration, how many reads on the production, and it also records counters, system counters on the source system, as well as wait stats. So which basically gives me the opportunity, if I would like to have this mother of all baselines, and I haven't set up an analysis customer in the first place, it doesn't matter. I can gather this information later as well, which is cool. So this is what this database is around, and I really love the idea that Gianluca has made this a SQLite database, because that's all the tool we are familiar with. Of course, it's not T-SQL, but standard SQL is not that far away from what we're doing here. So next of all, let's look at how to perform a replay. I've got some demo code for you in Azure Data Studio notebooks. I guess most of you will know Azure Data Studio by now. It's a great lightweight tool for query execution, and despite the name Azure, I'm not big of an Azure guy, by the way, it works like a charm on-prem as well. And the cool thing are these notebooks. They're originally from the data science background, which enable us to have some documentation along with some code with already results in it. So it's really a great tool for doing a demo and enabling you to follow along. So first of all, for doing a replay, I'm restoring my database. So I'm doing this on SQL on Linux. If you are on your Windows machine, you might change the backup location, of course. So I'm restoring this. That I have a consistent starting point. In my scenario, of course, it's pretty simple. I'm not performing any diff backups or log backups here, because it's just a demo environment. So next thing on, while this is running, is configuring query store. So if you have SQL 2016 and higher, using query store is really cool. And for this demo, I'm setting it up to capture all queries. So query capture mode all. This is just for demo purposes. Think about it twice. If you're running it on production, it might be okay. If you've got a lot of ad hoc queries, maybe it generates some overhead. So I'm nearly done with the restore now. I'm then configuring query store, as I just told you. So now it's a little bit sluggish here on my end. Let's hope this gets better. So go on. So no, that was one too far. I've got query store here. So we're ready to perform the replay. Here's the config. Again, we're reading with we're performing a synchronous replay from the capture already done, and we've got an analysis consumer to write the analysis results to database workload analysis in the schema baseline, and we've got a replay where it is configured how to perform the replay. We are connecting to the local instance on Stack Overflow 2010 database, display some stats, and discard results and some other options you can read about. And now I'm ready to simply start a replay. So I'm copying that. And I'm heading over to hitting enter. And the replay is running. We also already get some messages. We've got performance rows aggregated, and we've got also messages, 3,000 events queued for replay. We are already 28% into the replay. And we can have a look at my instance. Now we should see that there's something running. Yeah. So we've got activity, we are performing the replay. And of course, I'm not boring you to perform the replay now for half an hour. That's too much. I could do dancing like my mentor Uwe Ricken does, but it's not that much fun in a session. So I'm simply hitting the stop button. Here's now an ugly error message, but it doesn't bother me at all, because I just give the replay the hammer and said stop the old replay, so that wouldn't occur normally. And now I performed all this replay. And basically, I would now go ahead. I've conducted the replay. If I'm using Query Store, I would clone the database, which is a really great tool for preserving Query Store information. more about that later. And you can see I have in this clone here, which acts like a normal database, I have the query store information accessible, and then I do preparations for the second replay. So I'm just restoring the backup again. It's the same. I'm setting the query store again. I'm creating a new schema in the workload analysis database called change and dropping all the objects in it if I already have that schema. So I've got 0 tables. And then, of course, I'm going to introduce a change. So just for your information, this Stack Overflow database in its vanilla shipping, it has only one clustered index per table. I'm running pretty nasty reporting queries here, which of course, could leverage some indexes, some non-clustered indexes. I've also gone for filtered indexes here. I'm creating them, and then I should see a difference just for the demo. I'm configuring the second replay, and there's nothing too much different here. It's just I'm writing to another, the analysis to another schema, and that's all. I'm running the replay and cloning the database again. So that's how I would conduct the replay. And all the material, all the notebooks, all the instructions are on my homepage for you. I've already posted a link, so you can go ahead and play with it on your own test environment. So now let's go on and look at workload analysis. So for workload analysis, I first restore my workload analysis database because I fiddled with it. I've just started a restore. Oh, and it's in use by the session. Oh, it's so great to have some error messages. Now I have to read a bit. It is recommended. Okay, we're gonna use master. It's always something to be learned, especially if you have, so yeah, now it's restored, it's not too big. And then I start workload viewer. And I have this big, ugly command line call here. I simply execute, which is telling where to find the information about the baseline and about the change in which database. If you start workload viewer without it, it comes up with a GUI interface where you can put all of this in. But I'm taking a shortcut here. And that's how it looks like. I've got to create filter pane here, which would be more interesting if I would be running a production workload and not just my generated data. So I can see the application name, the host name, and so on. And here I've got my overall metrics. I see CPU usage, so CPU time, elapsed time, aka duration, and batches per second, all compared with the baseline, that's cyanogen line, and the black line, which is here called benchmark, which is the change, namely the second, the thing I would like to release. And I have to admit here on my laptop, these results are pretty inconclusive, nothing pretty to be shown here, but you get the impression if you're doing this for your production workload, you can look at it, you can click on it here to see the points. And of course, you can drill into more detail. So here we've got the queries. We've got a tabular overview over the queries, and Gianluca does a great job. If you, for example, have an ad hoc workload where user issues like select from users, where location equals Heilbronn, where location equals London, where location equals Seattle, that would be 3 queries and 3 plans for SQL Server. Typically, Gianluca already aggregates that, which is really nice. So I see this here. I can compare the metrics, and hey guys, it's amazing. This is a free tool. And I can look at details for one query as well. So I can zoom in here and can see, oh, okay, how about the duration for that query? I could like enhance that, get the selection of a window, scroll in, scroll out, whatever. This is really nicely done. And I've got a great impression over my workload I have. Now I've got to speed up a little bit. Let's go on. and look at the second option we've got, which is query store comparison script by John Starrett. By the way, John Starrett is doing a great, I don't know if it's great, I think it's great. He's doing a presentation at the end of August in a past virtual chapter. So I think it's data architecture about replay using database experimentation and assistant. You could go to it as well, and I'm sure he will talk about the script as well. Anyway, what I'm going to do here, I just copy all the data from the query store clones to my workload analysis database. So I'm going to create a schema first, then copy all the data. I've also got an aggregate table where I'm writing aggregates per query hash. And then John suggested that it would be cool to have a clustered column store index. So I'm not pretty much a column store guy, but hey, I've got a column store index. Probably wouldn't be much of this difference with my data. But anyway, we've got it in here. And now I can see, yes, I've got results, I've got data in these query store tables in my analysis database, and then I can conduct the final comparison script, which is here, and I really got a nice tabular overview. I can look at the executions in the second run and in the first run, compare and baseline, which is called here. And I've got a delta of 0, which is good, meaning that the runs are comparable. And I can quickly see, yes, my index is very effective. I've got a duration delta, which is high, and also, of course, a read delta for all the nasty select reporting queries. And if I go a little bit farther down, I can see, well, I also get some, one second. I also get some, let's look at the read delta. I also get some queries which now have more reads. What about that? Of course, these are the insert statements, so they don't profit as much as the select queries. They have to do harder work, and that's also a great example about the balance. Of course, you typically can't have an index for every query. You also have to think about the right activity, and conducting workload tests, you have a great tool at your hand to look at that. In that case, I wouldn't be too concerned. The savings here are really high compared to the extra cost down here, but it depends. And just here, a quick example. We are really used to looking at numbers. I'm not too much a number guy, and Azure Data Studio has charts in it, not only in the notebook, you can also have it in a normal query. And then we can quickly have a vertical bar chart and see, yes, we got better using regarding our duration, and we don't have any degradations in our queries. So in that case, I would say, go ahead, put it onto production, and open the champagne. So that's what analysis is all about here. Okay, and last but not least, of course, we can look into plans. I would go over to Management Studio. There I could open the plans. You can see the XML, of course, is here in Query Store. We have all that option. Typically, I would use this only for some tricky scenarios where the overall numbers don't suffice to give a clear picture. So heading back to the presentation, let me show you some tips and tricks. First of all, in my experience, a logging table can come in handy. If you don't have one, I'm simply meaning a table that has at least one datetime column and has a record inserted continuously, for example, every minute. Typically, systems have like such a logging table and are very chatty. But if you don't have it, you can simply set one up using an agent shop. That's not too much difficult. And why would I be doing that? That's a great tool for monitoring the replay speed. I had some issues with that. in the first versions of Workload Tools. And if you have got a 10-hour replay, you'd like to have some progress bar. Gianluca is already doing something like this using the events. But in my point of view, it's also helpful if you really look at how much am I into the replay. Typically, your events are not equally distributed. There might be a long pause in the replay or something like that. And then you can say, okay, I'm running the replay now for 30 minutes. I should be 30 minutes into the replay. Oops, I'm already only 20 minutes into it. What's going on there? So that's a little bit of a help. Optimize the restore. That's the thing about point-in-time restore. Typically, on a production system, having mission-critical data, we would be doing log backups, and then we can run a marked transaction at the beginning of the capture, saying begin transaction with mark, doing something, then commit it, and we can restore all the logs using with stop act mark capture start, which is really nice. Of course, you can also go ahead and using stop act and the exact time recorded. Workload tools give you that as well, but I think it's more convenient just to name it instead of copy and paste it over and over again. And you can leverage database snapshots to speed up subsequent restores. So just think about it. You have your backups somewhere on a server. Then you're doing all the restore. You're applying all the diff backups and log backups. That takes some time. So if you are in standard edition on SQL 2016 or have enterprise edition, I would do a database snapshot after I've restored, and then I can just change it back very quickly instead of doing all the restore again. So that's for tips and tricks. Let me quickly share some lessons learned with you I had on my journey on presenting and on that use case. So first about workload test. I really have to say it's a complex topic. Make sure to reserve enough time. For example, I did carve off 1 hour here, 1 hour there. Then I didn't thought about the problem for 3 weeks, and I was completely out of the process again. Doesn't make too much sense for me. The winner road was that we had an opportunity in the company, Bertelsmann company, to have a project week for like private projects, and I had a nice team. I worked with one week to get to know the tools better, and that really made a difference. Of course, I hope now you have my nice presentation that I've give you a little bit of a head start, but anyway, you have to make sure that you have the time to think about it. Then if the database is like your own database, so for example, in my example, the company I work with, they develop their own portal. So all of database code is by the own developers, and they are to be blamed, not a vendor. If something is odd, and there are interesting things, we like to access tables which have been deleted months ago, and then you go into the replay and say, what? That's something which typically doesn't surface in a normal prod system because it's user error and nothing cares about it. But here you can see that very quickly and have a nice feedback loop. What's that all about? And occasionally it might make sense to manipulate the workload. Think about it, but you have the possibility. It's SQL. You can do an update statement, whatever you would like. It would work. But also be aware that all activity on the databases is recorded. So this was not a big issue for me, but I've read about it. Watch out for backup commands. Of course, you're doing backups on your production instance. You're doing your capture. The backup command could be also within your capture. So for my example, I'm using Ola Hallencrane's maintenance solution. Then it's not that too bad because Ola just makes a new backup with a new time, with the server name and so on. It would be, well, I'm not sure if I would run backups during a workload test. You can think about it philosophically. Yes, it's part of the workload, but why should I do that? Anyway, make sure that this doesn't interfere with your production backups, at least. So, thinking about presenting, for me, it was quite hard at the beginning. You have to really set the scope of the presentation. I originally thought talking about the Microsoft side database experimentation assistant as well, and then I realized it's gonna be A, too much, B, I'm more invested in Gianluca's tool and convinced of it, so it wouldn't have been a fair comparison. If you're wondering about that, I really recommend John Starrett's presentation at PASS. And the demos needed more time, as I originally thought, which was quite interesting. I thought, oh, you write a demo, that's pretty easy, but then it turned out to be more challenging, and especially creating a repeatable workload is more challenging. So first of all, I went out, and Brent also has this great script, execute a random query. And I say, hey, cool, I'm gonna leverage that, execute a random query. But of course, the workload just captured the call to the procedure execute a random query. So the workload results were not comparable after it, because each time it executed a different random query calling that simply that procedure. So I had to make it a little bit more deterministic here. Yeah, and that's already all, folks. I'm a little bit excited. I hope I haven't talked too fast. I see we've got plenty of time for questions, and I'm really happy to answer them and have a discussion with you. And if also something is unclear, if I spoke too fast, feel free to ask about a clarification. So Kendra, how we are doing?
We're doing great. Just had to find the unmute button there. So you've got, if you can bring up the Q&A panel, we have a lot of really, really good questions for you to take a look at. So the first question is, can you create your replay system on Azure VMs or other cloud things? Do you think that would work well?
Gianluca wrote about it. He has made some modifications for Azure as well. Basically, the cool thing about Workload Tools is you can run the tool set anywhere. You can run it on your local client, for example. And if you're thinking about Azure, at least I would say, I'm not too much into Azure, but if you have a VM, if you have a Windows there, you could, of course, install it. Otherwise, install it on your local machine or on a server you have. So, yes, definitely.
Cool. All right. Another question is, does capturing the workload itself on the production instance impact performance?
That's a good question. I'd say, of course. There's the cool thing. If you are monitoring something, you're already changing it by monitoring it, you know. But also, I'd like to quote Brent Osa here. He says, "I've got a speedometer in my car, and if I take it out, well, I could go faster, but I don't know how fast I'm going. So it's really negligible here." I've been running on my production system a workload for a whole day for 10 hours. And this was not noticeable to me. I have to admit, I'm not in a high transaction environment. Anyway, you have got different tools. If you are modern and you go with X events, you probably know X events is the best way to go for monitoring something, and then the performance overhead is related primarily to the X event session.
Fantastic. Yeah. X events has so many more opportunities to filter and limit things in more effective ways than the old trace does. But wait, there's more questions. People really liked this session and asked us some really good questions
Cool.
here. So
lovely.
Here's another one. And this one is from
I'm reading Beardy's question.
Yeah, Beardy's question. Yes, exactly. Do you want to go ahead and recap the question and answer it?
I've already got through it. So it's about production instance with high specification and the necessity to pay for a test system with the same spec. Yeah, I have to admit that can be an issue. You have to think if you're doing any if you're making compromises, what would they be about? I've been asking my good friend and mentor Uwe the first time, maybe he can add from his experience. I'd say if you've got comparable CPU or and a disk, for example, is not too much difficult to save here. So if you're looking at logical reads, for example, it's not important. Then you're not looking at the duration of the query. You're comparing the reads, for example. They are consistent if the data is in memory or if it's on disk, if it's on SSD, whatever. For example, I would go with that road, and I would simply like to think. Let's put that offline later. Beardy, if you have more questions, I think we could discuss about it about 20 minutes or so, but I've got some ideas regarding that. Uwe, would you like to add something?
Yes, yeah. So yeah, the biggest problem is if you compare CPU, just for an example, if you have a lower CPU on the test system, it doesn't work for you to compare the CPU times. But what should significantly change if you compare index strategies, just as an example, is what you have mentioned, is the logical I/O. Just as an example, if you implement an index and you see that the I/O is dropping, then you see that it works. If it takes longer, then it may be because of slower disk systems or slower CPU. So it's quite hard. So when I'm working in banks in Germany, they are required to have exactly the same system specifications for a so-called UAT system, user acceptance test system, as for production. So in big companies, it's way easier to handle workloads like you have presented.
Yeah. A similar thing, I was working with a client with a very high transaction system once, and we just upgraded the hardware, right? We didn't change the code. We just moved it to a server with more memory and faster CPUs. And our bottlenecks totally changed, right? We went from having, because we used to have a CPU bottleneck, and now suddenly we had a lock-in blocking bottleneck, right? So, and that kind of is a similar thing. It's really hard to compare workloads on different hardware. It's a very difficult problem to solve. Yeah. Good question, because it is hard. All right, but wait.
I'd love to have a further discussion, but let's go on with a different question.
We've got more questions. So what about backups, index maintenance, and other job workload that might be running on the system? Will these be captured and run on replay systems in test?
I'd say typically yes. So that's the thing I've mentioned. Watch out for it. I think I've read an issue on GitHub where somebody was mentioned. Oh my gosh, I've got my backups in there. You've got all the activity recorded. Do your due diligence and look into it. It's really rewarding to find out some really strange things going on. That's the first place, and make it sure that you don't mess around with something. So, for example, for backups, it would already help, I think, if the test server can't access the backup share, then all that will fail. If you're using OLA's scripts, for example, in my context, all this is handled in a separate database. I'm not recording that database, so this is not a part of the workload recorded, for example. And even if it were, it would do a backup of the system, but of course OLA handles it for me that it's not the same name and not the same time as the backup on prod. So they don't interfere, but I still would be concerned about the space on the backup disk. So that's something, in my opinion, which doesn't have to be.
Yeah.
You know, the very, very cool good thing is Gianluca is here in this channel too.
Yeah!
So yeah, you see him answering it here.
The founder himself.
Welcome, Gianluca. Let's see if maybe I can even promote you. That would be fun. Let's see if I can promote you. Yeah. You didn't ask to be promoted, but you're gonna, let's make sure I click on the right person. There you go. So congrats, you're now a panelist, Gianluca, if you would like to actually chime in. And by the way, for those looking at the Q&A, there are comments on the Q&A that you can see as well. So you can actually see some comments that others have made on the questions. Question about, what about environments with high availability, such as mirroring? Any best practices or tips?
I've not been down that road, to be honest. Possibly you would like to fiddle with the workload, I guess, if you want to ignore the mirroring component of it. So that's just also always a philosophical question. It's part of the workload. Yes. Do we really want to test it? Probably don't know.
Yeah, you could. So when you're doing the replay, you could restore the database and you could put it into you could set up the exact same thing and then run the replay against it if you are interested in making it even more production-like. That's a good point. Yeah.
Maybe the results, if you have a high availability solution with always on availability groups, might be if you test it on a single server, let's say if you have a synchronous commitment mode, then the inserts will be a little bit faster on the test system than on the availability group system. And all this, so I think it's quite hard to compare both.
All right. Let's see. So a lot of these questions do already have sample answers on there, but for folks who are watching the recording, I don't actually know if they'll be able to see the Q&A. So I think it's good for us to cover them live as well. Can the tool be used on databases in AWS and Azure? I'm guessing this includes things like Azure SQL database, managed instances, Amazon RDS, these cloud databases.
Typically, I'd say yes. Maybe Gianluca can add to this. I don't see why it couldn't be used.
Yes, it can be used on Azure SQL database and managed instances. I never tried it on AWS.
Yeah, I bet if it works on Azure SQL database, I bet it works on Amazon RDS. I bet it does. Question, does the test system need to have the same version and edition of SQL Server as production? And if not, I guess, what are different ways you might or might not have that, have it be a different version?
That's a great question, I think, because of course, one scenario you would use that is if you're thinking about upgrading. You have SQL 2017 in production, you're upgrading to 2019. Great use case. Of course, you can do that. You can't do this, of course, if you're running a lower version, if you like, on production 2017 and on test, you only have 2014 because you can't restore the database in the first place.
Yeah, you do have to be able to restore the database. And that actually, so I was looking at this the other day. If you're thinking about something like an Azure SQL database or an Azure managed instance, I know that right now, at least for Azure managed instances, it doesn't let you restore the backup to an on-prem SQL server. It has a check in there now that makes the restore fail. So you could run the replay against another copy on a managed instance, but you might not be able to run it against an on-prem SQL server because you do have to be able to restore the backup.
Okay.
Is it possible, and we are over a couple minutes, is that all right to keep going with the Q&A? Are you good with that? Sorry about not checking in on that.
I'm fine. Just mentioning one thing, you should see the contact slide. Shoot me an email. I'm active, a little bit more active on LinkedIn than on Twitter. You can contact me there. Make sure that you download the presentation, play around it on your own systems. And I'm sure, speaking for Gianluca as well, we are very open to answer any questions that may arise.